Hey, so these are interesting times in this work of gravity control, gravity modification, understanding what it is, how it works, which has been my intent and my goal on this channel and in my work in the last few years. Um, so Salvatore Pais has come out. He's been with a paper and he's been uh, sharing more publicly. They came out with something called the Superforce, and basically, it's a it's related to the Einstein field equation for modifying space-time. And so what he says there is that he relates gravity to um, the speed of light. So in the equation, it's c to the fourth power. So in a modifiable speed of light framework, which is what seems to be uh, the possibility and seems to be the missing, the key ingredient to understanding gravity uh, as a modeled by a variable refractive index of space. So the electromagnetic refractive index uh, that can be modified by mu and epsilon. These so-called uh, permittivity of free space and permeability of free space are actually modifiable, and this is the big secret. And so when these change, then the speed of light locally changes, which then affects the ability of bodies or masses to interact gravitationally. So it shifts it, it modifies it. So this opens the door to a lot of new possibilities, and for me has been an important puzzle piece that ties together a lot of things that I've been seeing. And what I want to do is show in this video is an experiment I did recently to look for and kind of chart out the relationship between temperature and weight of some water. So why that's important, I believe, is it's a small amount of weight change, but the way it changes its weight is what's interesting to me, because turns out this is actually right on engineeringtoolbox.com. If you go there and you look at the relationship between density of water and temperature, it actually gives an example there of a case of hot water, how much it weighs versus when it's cold at 4 degrees Celsius, and it actually shows the calculation. Um, but it's like no one has stopped to really connect the dots and say, okay, well, why is it changing weight? It's not supposed to change weight, and the amount of displacement of air, to cause the buoyancy, to cause the so-called lift from buoyancy by expanding the water, by heating it up to displace the air, that just does not add up. So so you'll see in this video an example of this experiment. And I brought the water basically to a boil, and through the whole curve, you'll see the curve of weight loss, and then it recovers as it cools down later on. So why this is important, how this ties together with the Superforce and this idea of a variable refractive index as a model for what gravity is, is because when a lot of materials, when you change their temperature, you actually change their permittivity. So in the case of water, this is well known, and again, it's on Engineering Toolbox. You'll see the electric permittivity of water at near boiling versus when it's at cold, 4 degrees Celsius, close to freezing. So there's like a difference of like 30 times there. From like 80, water is like 88 permittivity, relative permittivity of like 88 at when it's cold, and when it's hot or close to boiling, it's more like 55. So there's a huge reduction there. So, which implies a change in the speed of light. So this is all very interesting, and we've also confirmed this in heating and cooling wax. So not just water, and I've done a number of experiments with heating and cooling metal, sand, in vacuum, not high vacuum, but roughly 3/4 of the air pumped out, just due to the limitations of my system. But so most of the air out, the effect is still there. As far as like practical applications, we're not there yet with this. And changing temperature is a method. It seems to be a method. But in and of itself, I'm not saying this is, going to make the only way to anti-gravity or to loft a vehicle and overcome Earth's gravity. Although we do already, in a sense, have that. Let's just say there could be more to air balloons, to aerostats, airships, dirigibles than commonly thought in terms of what actually causes the lift in those, especially when the temperature of the gas, the lifting gas inside the balloon envelope, is allowed to change. This is something that I've never come across it in anything that I've read or studied when it comes to fluid dynamics. So just if you imagine that the refractive index dictates the speed of light locally, and that is modifiable, which is well known in astrophysics too, because they see the gravitational lensing effect across the universe, and so light is being bent, refracted through space by gravity, as they say. Well, doesn't it make more sense to say the refractive index of space is changing, therefore the light is then being refracted? So, and then what causes that is dictated by the permeability and permittivity of free space, which is thought to be fixed in all reference frames. So if we just say, well, it's probably not. If it's not fixed in all reference frames, if it's actually modifiable, then we have a mechanism of gravity, because it bends light, and that's what gravity is known to do, bend light. So I think it's one of those things of the language that's used that causes the confusion. It's this term gravity, and it's like, well, what is it? Well, it must be something separate than electromagnetism. It can't be. But this is at least the way I see it right now, and I'm no theoretical physicist, I'm not a physicist, although I have studied some physics, but it makes sense. It seems to be a unifying principle, and Salvatore Pais is not the only person that's made these connections. There's been others. I'll mention Todd Desiato and some of the other of his associates. But yeah, many have been working on this theory of GEM, gravito electromagnetism, the unifying of gravity and electromagnetism by a variable refractive index, which is an electromagnetic phenomenon. It's how the medium, the vacuum, propagates electromagnetic energy or radiation. And it seems quite, evident that we can change that by modifying with high intensity field energy locally in space or in a body or in a material. Its refractive index changes, therefore the speed of light changes, therefore it's the gravity of a mass or body changes. So we're all told that everything has its own gravity. A bowling ball has its own gravity field, an apple has its own gravity field. So if you modify that gravity locally by changing the refractive index locally, say by heating or stressing the material on one side, you change mu and epsilon, you change the speed of light locally, you change its gravity locally. So what ends up happening then is you get an unbalanced force because the gravitational field of the body is modified. And this is the key idea behind a warp drive. If you've got a craft or a ship and you modify the gravity, so you make the gravity a little larger or more larger on one side of the ship than the other, you have an imbalance in its gravity, its own gravity field. So the matter, the mass around the center of the vehicle or the ship would be attracted towards the space that has the higher gravity, or the higher, in this case, what we're really talking about is the permittivity and the permeability of the space on one side versus the space on the other. So this is what I think is the key idea, and what is happening in these experiments and observations that I've seen with varying temperature of materials and fluids and gases. And I just want to point attention to, pun intended, the pointing vector being a physical manifestation of this as a result of these crossed E and B fields in space, that it causes an actual current, a movement in space, in the medium, in the vacuum. And this isn't what electromagnetic power is. It's known to follow the pointing vector is the direction in which that electromagnetic power flows. So again, there's a language thing, you know, here is electromagnetism, here is gravity, relativity, and all this. Because of a few language barriers, these two worlds don't cohere and come together in unification. So, but I think these are the key ideas. I really think, again, I'm not the first to put these dots together. So, shout outs to everybody who has been working in this field a lot longer than me. But I'm grateful for those who have and who've shared that knowledge. And I hope this helps somebody else, some other researchers out there who are just trying to put the pieces together themselves. Here's the experiment I'd like to show. And again, on this channel, I have other videos about this kind of thing. So at risk of over publishing on this particular thing, on this particular phenomenon, I'll share this experiment. By the same token, I don't think I've really communicated that well this data and what I've found and what I've discovered here in the past. So I'll just keep publishing. I don't know. And hopefully it'll catch on, and we'll see. I don't know. What I was really trying to prove to myself was the active change in weight as a function of increasing and decreasing the temperature of the fluid, in this case water. I've seen this weight change with water vapor and heat lamps, but never got around to actually bringing the water to a boil well on top of a scale. So in the top part of the screen there, you'll see some water at the bottom of a kettle heating up, approaching boiling. You notice the waviness or the refraction patterns of the light going through it. So it's well understood that changing the temperature will also change the refractive index. This is what I was highlighting at the beginning of this video, and what that means and how that applies to the gravitational force. So the temperature probe there you see is approaching, just passing 70 degrees now, and as you can see there's no weight change yet, and it's just starting to boil. These clips are running in very high speed, time lapse. So the jar is it's a styrofoam block wrapped in aluminum foil for insulation. Notice how it approaches boiling. There'll be a very sudden change in the reading on the scale. And now I'll show a clip of it heating up here at ludicrous video speed, so you can see the expansion of the water, the change in its density. So after turning the power off, noting the loss of weight there of about 1/4 of a gram, an almost boiling point. So now notice how the weight continues to drop long after the power's been shut off here. And the temperature is dropping now under 80 degrees, but notice how the weight continues to drop. And I think the fact that it continues to drop, long after the power's been shut off and it's no longer boiling, suggests to me that if the reason for the weight loss was just loss of water vapor, that would have happened much earlier than this. And if the reason for the upward loss in weight had to do with, say, convective air currents rising up against the side of the jar, and then friction from that causing a bit of lift. If that is the mechanism of weight loss, that would have happened much, uh, much further before this, because as you can see, the temperature has dropped 50 degrees here, and yet the weight loss persists. I want to just point out again that the lid is on loosely, so uh, to allow for vapor deliberately to escape if the pressure would get high enough. So if you could stick around to the end of this clip, not only does it help the video's success and the algorithm, but also you will see the return to baseline or zero here, which I think is pretty damning evidence to some of these conventional explanations. I was actually surprised by the speed at which the balance returned to zero as the temperature approached 20 degrees or 10 degrees. So just for perspective here, this is actually taking place over 2 hours or so, 2 or 3 hours. The interesting thing is there seems to be a hysteresis in terms of relationship between temperature and weight, and the non-linearity. So as you recall it, as it was just about boiling was when it really started to lose weight quickly, and then after the power was shut off to the heating element, it continued to lose weight even as the temperature was dropping. And now, as it approaches the background temperature, which is about 8 degrees Celsius, the a majority of the weight returns. The rate at which it returns becomes increasingly fast. So just for the sake of time here, I'm going to double the video speed relative to the other clip. So here is the graph again. Notice there on the left is delta grams, which is the green line. On the right, temperature, which is the red line. Notice the correlation there between the two. So it's an indication of weight change, or weight with respect to temperature in degrees Celsius. So I'll just quickly show here the 500 gram calibration weight, just indicating that the balance is weighing accurately and repeatably, that there's no malfunction. I hope that some of you will find this helpful or interesting, so if that's the case, please like the video or make a comment. And until next time, here's my corny outro. Keep failing forward.